We're at one of the local Chattanooga parks working on a drone survey, and today we're going to take you up in the sky to show you the basics of how easy it is to actually take your drone up, do a quick orthomosaic map, and take a 3D model of whatever image you might want to take. So we've got our Phantom 3 Pro here. It's got 4K resolution for the video and 12 megapixels for the picture, for the images. We've also got the standard controller that comes with it, nothing fancy. I'm actually using just my cell phone with it. It doesn't take any fancy tablet. You just plug it up and straight and go from there. So we've got our setup for our ground control point units. We're gonna do 4 of them out here today. We're gonna set them at the different corners of the site. And we've also got our GPS unit that we're gonna use to take high accuracy ground control points. So I've got one of my ground control point units here. I'm gonna put the GPS unit right in the middle of it so that I can get an accurate measurement. And what it does is it gives the drone a relative area so that the elevation based off the GPS unit can tell it exactly where it is in real time. You can give it elevation data, and it can also give it horizontal accuracy. So we've got 1 point recorded here, and we're going to do 3 more going around the whole site just so that we can have the whole site contained and know exactly the elevation that we're going to be working with. Lets the GPS get it actually locked on to all the satellites that are here to make sure that it's actually doing what we need it to do. Alright, so I've got the mission loaded into the drone. I'm going to send it up, and it should be an autonomous flight from there. we've got the data syncing up right now to the drone. Well, after this, we're going to take you back into the office so that we can get it all uploaded. We're going to turn it into a 3D image, and we'll also turn it into a 2D ortho mosaic. So we're going to start off by importing the images with the elevation metadata into Web ODM. Here we can change a few of the options to optimize the quality of the processed data. I have my images set to 1000 pixels because with 32 gigabytes of RAM, my system can only process about 60 images at a time. The developer recommended that with WebODM, at least 4 gigabytes of RAM is necessary to run the software, but in my case, 16 gigabytes weren't enough. Along with the 16 gigabytes of extra memory, I'm currently running an i7 Intel processor with an NVIDIA GeForce GTX 950 graphics card. As the images take some time to resize and process, I will skip ahead. Okay, it took about 24 minutes to complete. And let's check out the ortho images that were generated. There are a few small images that we can correct in QGIS, but ultimately this map turned out well. We can clearly see what's going on at the site, and our image is higher quality and more up to date than what Google satellites depict. There are a few neat things you can do with the tools on the right side. We can measure length, area, and volume, all of which can be exported as a QGIS ODM, which can be imported into QGIS. It's also much easier to create contours from the which we'll later import into QGIS. Here we can also take a linear measurement from the two different points of elevation. There's also a plugin that allows you to analyze plant health, so if you work in the agricultural field and your drone has a multispectral sensor, you have additional options. Here is the digital surface model, which is created by combining the locational data and the aerial imagery to generate a model that can display the elevation above mean sea level. Next, we can see what our 3D model looks like. The grid above the model depicts the location of the camera at the time the photo was taken. You can click on the icon and it will show you the image associated with it. The software can be beneficial for anyone working with crime scenes, emergency relief, construction, asset management, and plenty of other opportunities in the agricultural world. There are a few other options here on the left that you can mess around with, and some will allow you to manipulate the size of the point cloud, which will allow you to analyze your data in higher quality. There are a few other options here on the left hand side which you can feel free to dive into. I didn't say it before, but this software is free. You have to go through a few hurdles to install it, but it is free. Now that we've deselected the texture model, we can accurately see how the cloud point model changes once we change the nodes. There are some clear holes in the model, and according to one of the developers, these can be eliminated by performing multiple flights. We can clean up the area of interest with the clipping tool. This will allow us to eliminate some of the messier sections of the model without losing quality. Next, we will skip over to QGIS, where we will make a shapefile from the text that we created from the ground control points that we collected in the field. With the use of our measurement tool, we can tell that we're about 11 feet off, so we will try to georeference the area to align the map. Now that we can tell that we're about 11 feet off the Google satellite image, we can georeference the ortho map with If done correctly, we should have an accurate map that is aligned to the ground control points. Lastly, we can drag over the contours that we exported from Web ODM to create a digital surface model, which can be used to create hillshades and an elevation model. The last thing we're going to do is label the values of the appropriate data to display what is above MCL. With a simple drone, Web ODM, and QGIS, we can create our own digital surface models and generate up-to-date orthomosaic images in real time.
That was excellent. Thanks, Jeremy, for that. There's a couple of questions that were asked. What type of GPS unit were you actually using when you're capturing those ground control points?
So the rover that I'm using is the Carlson BRX5, and I'm using a Trimble Nomad to collect the actual points.
Excellent. And what about the mission planning app that you're using on your phone? Which one were you using there?
I saw someone mention that it was Pix4D Capture. That is correct.
Okay.
And I also saw that someone asked a question about the Ground Station Pro app. I've heard a lot of good things about that one too. I haven't tried it yet and I can't speak on it, but
yeah,
I have heard that it's pretty beneficial for that program also.
So what would you say, like if you're going to use something, one of the commercial software versus ODM, what are the limits of ODM compared to something like, let's say, Pix4D?
Oh, basically, it's just a lot of the, like I'd say some of the more commercial softwares are a little easier to use. It's a little easier on the user side and hardware side. As you noticed, when I was processing some of my data, there was a lot that I couldn't do. And since then, I've learned that there's a few settings that you can play around with, but it's a little bit more intuitive on the commercial side for some of the other products.
Right, or a little more streamlined, yeah.
That's right.
So there was that question about the Ground Station Pro versus other things like Pix4D Capture and all that. Have you used other capture tools? Have you sort of tried any different ones before you settled on using just Pix4D Capture?
I've tried Litchi, and there was one other one that I've tried, but I can't remember it off the top of my head. But I'm always into learning more about these. That's just the easiest one that I found so far, but I have been watching a lot more videos specifically on that Ground Station Pro, and it's funny that they did mention that one. That'll probably be the next one I pivot to.
Yeah, it looks pretty cool. There's one question, how is volume measured? So from automatic or manually entered base elevations?
So the volume is measured, it's calculated automatically through the onboard GPS and the barometer, and that provides the elevation for the mean sea level. So you don't have to put anything in besides how high you actually want the drone to go up.
Okay, interesting. I noticed you were georeferencing the ortho that you brought into QGIS to the ground control points. Does that not happen within the software? It's actually generating that ortho?
You can actually do it that way. That's something that I've been playing around with it. There is an onboard app for Web ODM where you can create your own ground control points and just have that in an ongoing collection of them. So I can go back to the ones that I just did there and add a few more points to just a global map that I'd be creating. So you can have your own ground control points pre-established.
That's awesome. Well, this has been a great presentation. I think we have one more. How well does a filtering algorithm work to determine the ground?
That's a little difficult, especially since it just does digital surface models. I've heard that when you're using LiDAR, it's a little bit easier to get terrain. So that's one that I can't really speak on.
Okay. Have you looked into Web ODM Lightning for cloud-based solutions using Web ODM?
Yes, that's another one that I've played around there. That once you get the software up and running on your local side, they offer that to you for free. And that's just another one that I just haven't played around with much. I've tried to dump a few pictures into it, but I found a little bit more success just on my personal system. But I've seen a lot of people process a lot of good data with the Lightning version of it.
That's awesome. And a question about drones. Have you used any fixed wings?
No, not yet. That's something I would love to get into, especially for just the amount of data that you can actually collect. Not like, let alone that steps up your whole profit margin. It's a great opportunity to dive into those, especially now.
Yeah. Well, Jeremy, this This has been excellent. This is a subject that I always like to talk about. And thanks for presenting. Thanks for being a part of the conference.
Not a problem. Thanks you all for joining me. It's been a wonderful experience.
Thank you.